All right, guys and gals, once again, it is Coach Gu here with another fun-filled, action-packed, flipped geometry classroom video. And today we're going to be going over the second part of the trilogy of transformations. It's going to be reflections. So, what do you think a reflection is? Anyways, guys and girls, if you said flip, then you are right and you get a nice little high five. Bam! A flip over the line called the line of reflection. That's what a reflection is. It's a flip over a line called the line of reflection. And each point and its image are do you think it's the same distance from the line of reflection? Different distances? What do you think? It's the same distance. Oh my goodness. Same distance. Look over here in this picture on the left side. You see B? It's like this far away from the line of reflection. Then look at B prime. It's the exact same distance away from the line of reflection. All right, next. So here's some possible lines of reflection, some possible lines that we could be reflecting over. We could have the x-axis, the y-axis, some vertical or horizontal lines in the form of x equals a number or y equals a number. And we could have diagonal lines in the form of y equals x or y equals negative x. So we'll see what this looks like in practice. So let's go dive into the practice problems. Number 1. Let's take a look. So we're going to graph and label each figure and its image under the given reflection, and then we're going to give the new coordinates. And you're going to see some special rules about an easier way to think about these. So number 1, triangle ABC with vertices A at -4, 2. So we're going to plot these points. -4, 2. That's over here. That's A. B at 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 up here. And C at 5, 1. 5, 1. That's right here. Bam. So that's our original triangle. Take a look at that beautiful triangle. And they're telling us to reflect over the x-axis. Where's the x-axis? That's right here. So we're going to be reflecting across this line. So just to start with, the simple way, we just count how many spaces away is each point from the line of reflection, or in this case, the x-axis. And then we go in the opposite direction. So take a look at A. How many spaces away from the x-axis is that? It's 2 spaces away. So instead of going 2 spaces up, we're going to go 2 spaces down, and that's going to be A prime. So 1, 2. A prime would be right here. Where would B prime be? Well, if B is 7 spaces up, bam, 7, we would go 7 spaces down to find B prime. So B prime is going to be right here. B prime. And then C is 1 space up from the line of reflection. So we're going to go 1 space down, and it'd be right here, C prime. And if we did it right, when we connect our points, we should have an exact mirror image of our original. And do we? Well, it's not perfect because I didn't draw perfect. But it is a mirror image, so then we know that we did it right. All right, so now we need to give them our new coordinates. So what's the coordinate of A prime? So count the spaces. Left 4, down 2, that's a -4, -2. B prime is going to be how many spaces? Right 4, and then down 7, so 4, -7. And then C prime from the origin is right 5 and down 1, so 5, +5, -1. So now take a look at our new points and our original points. So the original A, what was the original A? It was -4, 2. A prime is -4, -2. B was 4, 7. B prime is 4, -7. And C was 5, 1. And C prime is 5, -1. Interesting. Is there a pattern here, guys? You see a pattern here? If you said that all the y values have a negative sign on them now, then you would be right, and you are a genius. Oh my goodness, yes, that's perfect. So with this secret rule, when you're reflecting over the x-axis, all you really have to do to find your new point is, if your original point was xy, then your new point would be x negative y. All we did was add a negative sign in front of the y value. So if you had your original point is 2, 1, and you're flipping over the x-axis, then you would go to 2, negative 1. If you started with, let's say, 0, positive 3, then you'd go to 0, negative 3. If you started with 2, negative 3, you'd go to 2, positive 3. Yes. So all you have to do when you're flipping over the x-axis is put a negative sign in front of that y value. And that's it for this one. Let's go to number 3. All right, this time we got a trapezoid. I'm going to go ahead and plot the points. You guys plot the points as well, and hopefully we have the exact same points plotted. So all right, so there are points F, G, H, and I. So we're going to have to find the new points over what are we reflecting this time? Over the y axis. That's going to be right here. Bam. And so to find our new points, once again, we're just going to count how many spaces away is each point. So let's start with F. F is how many spaces to the left of the line of reflection. It is 5 spaces to the left. So we're going to go 5 spaces to the right. So our F prime is going to be right about here. F prime. G is 2 spaces to the left. That means we're going to have it go 2 spaces to the right. There's G prime. Bam. H is right on the y-axis. It's 0 spaces away, so we don't need to move H at all. H prime is going to be exactly where H was. And then I was 8 spaces to the left. We're going to move 8 spaces to the right. So I prime is going to be right there. And let's connect our points and make sure it looks the same, just a mirror image. And yes, it checks out. So now let's write down our coordinates. What are the coordinates here? So it looks like F prime would be 5 spaces to the right and down 2 spaces. So it's going to be positive 5, negative 2. G prime is 2 spaces to the right from the origin and 2 spaces down. So 2, negative 2. H is this exact same spot. So still 0, negative 6. And I prime is negative. We moved 8 spaces to the right. So that's positive 8, negative 6. Okay. Now let's compare this to our original values. So originally, F was negative 5, negative 2, and F prime is 5, negative 2. G is negative 2, negative 2. G prime is 2, negative 2. H is the exact same as H prime because it started on the y-axis anyways. And I originally was negative 8, negative 6, and I prime is 8, negative 6. So do you guys see what's happening right here? You guys see what's happening right here? If you said that all the x values have been negated, then you are right. And that is the rule for reflecting over the y-axis. Yes. So if you're reflecting over the y-axis, all you have to do is, look at this. If your original was x, y, then your new point is going to be negative x, y. You just stick a negative sign in front of the x value this time. Oh my goodness. Oh. Exactly. All right. So that is number 3. And then finally, I'm just going to tell you the rule for if you're reflecting over a diagonal line, y equals x, then all you have to do is, here's the rule, check it out. If your original point is x, y, then your new point is going to be y, x. So all we did was switch the y and the x. So here's quick examples. Let's say we have a triangle with points x, y, and z. X is going to be, let's just say it's 2, negative 2, 2. Y is, let's say it's 4, 6, and 7. Z is negative 7, 3. Then our new points, all you have to do is switch the y and the x values. So x prime would be 2, negative 2. What would y be? What would y prime be? It's going to be 6, 4. And lastly, z prime would be 3, negative 7. So this is the rule for when reflecting over a diagonal line. So if you have these problems, try it out on your own. Try all the problems that we didn't do together in these videos, and we'll check some of them in class tomorrow. But until then, guys, that's the end of this video. Catch you in the next one. Peace!